In this video I have one of the less glamorous electronic devices, which is the microwave oven. It's really just a kitchen appliance, but this was one I saw actually lying on the side of the road, so I thought, oh well, I want to do a video on a microwave one day. I'll grab this one, and I doubt it works, but it may do because it's actually just very rusty inside where under the tray where that's been rotating on the rollers is all rusted, which sometimes happens with, especially with these cheaper ones, the paint just peels off, especially if people leave it wet and stuff. But I thought we'd have a look at one, and I'll basically scrap this thing out and get rid of it. My neighbour's actually after some magnets, so we'll pull them out of the magnetron as well, no doubt, although this might be a good mag. What is it? A Galan's. I do have an old Sharp somewhere too that's very low in power output, so I guess that's something else we could even discuss or look at, how you measure that, which you basically just do it by heating water. Now there's nothing radioactive in these things, despite some of the rumours going around as they were for years. I don't know if anyone still believes that, but basically it's just this device is a lump of copper, steel and a couple of big magnets, and it's basically a radio transmitter. So that's our magnetron, that does all the cooking. It just puts out a whole lot of radio waves, and that's basically it. A bunch of excited electrons that go in and shake your food around, vibrate it until it heats up. So that's basically how they work. But there's nothing dangerous or toxic in these. You do hear talk of beryllium oxide in the magnetrons. Oh, don't pull them to bits, but that was only in some very early, highly expensive sort of radar ones or something, radar magnetrons or something from way back in the 40s or 50s, 60s, whenever it was. There shouldn't be anything toxic in these ones, but you know, don't go out of your way to break the ceramic in them either, but you should be safe to bang these apart and get the magnets out of it. A couple of nice big ring magnets in there, very strong ones, which are a pinch hazard, so don't be careful if you get a couple of those out if you're going to stick them together or anything, because they will pinch your skin, your fingers and stuff in between. Fingers probably won't matter, but if you get the edge of your skin or something on those things, that will cause a world of pain and a big blood blister. So that's one of the main hazards with it. The other hazard with these is, of course, they start at 240 volts. Everything in here, besides some of the stuff on the control board, the digital timer there, that's obviously got a transformer on the back and steps it down. So that is lower voltage, but there's 240 volts all over the board because there's relays and stuff there. 240 volts into the transformer on it. And after that we go through a big transformer, or if it's a Panasonic, it'll have an inverter which does the same thing as a transformer, except these can only be sort of switched on and off. So when you're defrosting, you'll see that the oven will run at a duty cycle basically. So on for a period, off for a period, on for a period. That's how they control the heating. Whereas an inverter, you can actually control the percentage constant. So it's more like a rheostat or variac or something feeding the transformer. It's like you're changing the voltage. So the transformer puts out varying amounts of power. Though of course the transformer in those is in a electronic switch mode type circuit. But this thing steps up. So 240 volts comes in. Once the controller tells the relay in here to turn on. They've got safety gear in here, so if the door's open, there's no way you can start this part up. There's even often a monitor switch in there which can actually short things out, so if power does try to get to this thing while the door's open, it'll blow the fuse. It is one of the things to look at if there's a fuse blown in these things. But this converts up to around 2000 volts. It's actually negative, so you can't use a television high voltage probe to measure these because that only measures positive. You can buy a different kind of probe that plugs into your multimeter. So this is my one that I bought. Basically just earth lead, which is always got to make sure you put that earth on and make sure that's well attached and not going to come off while you're fiddling with it, because that could potentially go high voltage. And it just plugs into a digital multimeter. I think these were like $200 or something. I think I got it from Wagner Electronics, but other electronics places probably sell them. But you need one that basically, because your multimeter can measure negative with the voltage that comes out of there, whereas the old TV ones with built-on meter on them only measure positive. So this has got a diode sort of pointing to ground. So there's a big diode there. Some of them have a short protector across there, so it's just another diode looking sort of rectangular device across the two terminals of the capacitor. You've got the capacitor goes between, I think, the transformer and the diode. The diode points to ground. The magnetron is basically earthed on the outside. High voltage goes into these two pins, but there's also a filament, so they put the high voltage onto the filament. And there's also a second winding in this transformer. That's why we've got two connections, but the ground is the main other side of the thing. As far as it actually powering the magnetron up goes. And this stuff is high current, like there's at least, I think, a couple of amps you can get out of these. I think those run at 2.4 gigahertz or something. So you don't want to run a magnetron, despite what Electro Boom was doing. You don't want to run a magnetron out in the open, because there's radio frequency energy coming out of that, and it can fry your eyeballs and stuff. He seemed to have got away with it in his video, but I wouldn't recommend running one of these out in the open. It needs to be inside a metal box. And in this case we have the grill, so you can actually see through it on the door there. And that's just because the wavelengths can't fit through those holes, so none of it gets out. I've never seen a microwave that really leaked. I've had a couple with a slight reading. I do have a microwave leakage meter somewhere. You just had to have one, because sometimes customers would ask you for it, and just to cover yourself, best if you ever worked on one, because sometimes you were repairing doors, the latches would get broken on the doors, other reasons you'd pull the doors apart, so you really had to check them before they left. And so it's worth having one of those. They did make a couple of designs in some of the old electronics magazines, and you could buy sort of cheap ones. You don't, just something that indicates, I think it's just a diode and a few bits that rectify the radio waves if it receives them. That's probably enough to indicate anything. You don't really need a proper calibrated meter unless you're in business or something. But this high voltage section, very dangerous while it's running. And if you're ever thinking of following these idiots on the internet that get one of these transformers and put a couple of probes on it to burn those patterns into wood, don't even think about it. It's the stupidest thing you could do on earth, is putting yourself across the output of one of these and holding a probe in each hand from it. That is just insane. 2,000 volts will go straight through you, and even if it doesn't kill you from stopping your heart or something, it'll cook you. So much current in these things, it'll go right through your body. And you know, once you get that sort of thing in you, it basically fries your insides. It can burn veins and all sorts of horrible things, let alone what it can actually do. It'll stop your heart and kill you, and all sorts of other injuries. You get puncture wounds in and puncture wounds out with these things, and all sorts of horrible stuff. So do not fiddle around with these things. It's best to never really touch these while they're running. You normally don't need to, but the reason I have that high voltage probe is sometimes you need to check the high voltage section to see if it's actually running, but the bulk of these can be diagnosed just with a multimeter. Most of these high voltage caps, of course, caps can hold a charge. They do have inbuilt discharge resistors normally. I think I only ever had one, but always that had a charge, but always get at least a known good clip lead or something and put it across the two terminal, one to the other. I think you normally just hook it to chassis, because the cap should be shorted to chassis. Do that, and then I always used to put them across. They did make a special thing with big probes on it, is probably even safer, but I only ever had one do a slight spark on me, because sometimes you will find the magnetron won't run, so that could stay charged, but they normally don't. But never ever trust a charge capacitor with that sort of voltage and current capability. So you have to be super careful, but generally you don't want to be touching anything on the secondary side of the transformer while it's running. You don't want to be touching anything in these at all, because it's all 240 volts mostly. But they are very easy to diagnose normally. The main failures are the magnetron itself, the high voltage diode. Sometimes that short protector will just go for no reason. I think the short protector was to blow the fuse or do something if the diode or some of the caps also go short in them. That was another thing. I used to replace a lot of capacitors, especially in the later model, these cheap ones. The capacitor quality went down. The old Japanese ones used to go forever, but like everything got cheaper and less reliable. So you do get shorted caps, shorted diodes, short protectors, shorted magnetrons is pretty common. And yeah, unfortunately they were quite expensive, so often wrote off certainly the cheaper ovens or the older ovens that people didn't want to spend on spend the money on them. These later ones actually have a fuse, a high voltage fuse. All the early ovens, if something went wrong in the high voltage section, it would blow your main ceramic fuse there. But that was, 90% of ovens came in for no power. One of the problems with these later ones too is these lamps. A lot of them used to, I think the Sharps and stuff, they were side mounted. And when the filament went, it would actually short something out and blow the fuse. So it was quite common to get the fuse blown just because the lamp had gone. I think I only had one instant of one that I checked everything and couldn't work out why it was blowing the fuse, but it turned out it was actually someone had spilt their baby bottle or something in there and poured milk down. Obviously milk had spilled out inside it and it had gone down into the turntable motor because the coupling for the tray just sticks up through a hole. And it was actually the turntable motor was shorted out because of that. So that's rarely you'll get that. Sometimes you can get these door switches will get all burnt up in the contacts or full of grease and they stick, and that can blow a fuse. But normally 90% of the time it's the high voltage section that fails in these things. Control panel's very reliable normally, but some of them used to get like certain keys wouldn't work and that sort of thing. You'd have to get a new keypad for them because the moisture would get in. They're just a multi-layer membrane keyboard, so you've got like this outer printed bit stuck on and then a couple of layers of plastic, and if a lot of moisture and grease gets on these, it can actually get in down these sides and underneath and between the layers and actually eat the contacts off. So you might get a track, you'll be missing one of the rows or columns or something. Sometimes just a few buttons, sometimes just one button. Not much you could do to fix those other than replace them, and again, very expensive. They used to be anyway. So it could be the death of the microwave. But we'll go through this one and I'll just do the normal checks. We'll assume this thing's faulty. So of course, make sure it's unplugged. Make sure your multimeter is working. We check the main fuse. A lot of these later ones you won't find the main fuse blown because it'll be the high voltage fuse. They didn't, like I say, didn't have those in the earlier ones. Now sometimes you could get problems too with these relays on the control board, but that's easily found. Normally you just do this basic test. We can basically check. Now I should obey my own thing, even though this one hasn't been plugged in for who knows how long. So we'll go to earth. I think I already did this anyway. We'll short out both pins of the capacitor, and when we've done that, without touching any metal on the clip lead, of course, we'll go across the capacitor. Then we can unplug our magnetron. You just pull the two. Not an easy thing to film, unfortunately, but you just pull these two spade terminals off. Oh, they're rather tight. Now the magnetron itself, two pins sticking out of it. You go to the case and we just measure to ground. Normally diode test is enough. If it beeps like full continuity, magnetron shorted. Sometimes you'll get a bit of a reading, still a dead magnetron. If it leaks at all, then it's gone. Between the pins, that's your filament. Don't know if I've ever had an open circuit filament, but I think I did have a transformer with an open circuit filament once. So if we measure across the two pins of the connector, as well as the magnetron, so between the pins of the magnetron, short. Between the pins of the transformer that we just unplugged from it, short. Now if we go to ground of the, or we can go to the ground of the magnetron, and from both those connectors we unplugged from the magnetron should be nothing. We can measure across the capacitor, nothing. Capacitor to ground across the diode, nothing. If it has a short protector and you measure a short across the cap, you unplug that and see whether it's the actual capacitor that's shorted or the short protector. We've got this big high voltage fuse here, a bit hard to see, but it's just a big plastic tube. It's got 5 kV, 0.7 amp written on it. That's its rating, so they do come in different amperage ratings. Goes between the capacitor and the transformer terminal, and it should measure short. If that's open circuit, normally it'll be something in the high voltage is blown. So you always have to remember to check that when you're quoting the customer, because they used to cost about $8 or something. Make sure that you check the fuse isn't blown. But this one's all measuring fine. I reckon this oven probably works. So I can plug our magnetron back in. Now another thing we have here is a thermal protector. So most of these were resetting types, but that's, you can see this brown wire, that's basically straight out of the power cord through this little filter to, I think, mainly stop noise going back down to the power line. From this you've got your inductor and 2 caps, and then it'll be this brown wire goes through the thermal fuse. If this oven's been too hot or gets too hot, like when the fan's blocked on the magnetron or something, that's why it's right near the magnetron. A lot of them were mounted on the magnetron. That'll go open circuit. If it's a good design, that'll just reset when it's cooled down again. Sometimes they just failed, I think just because they were faulty. I seem to remember it was a Sharp, a later model or something, they used to go open circuit and just stay open circuit, so you'd have to pull this horrible Euro style oven apart, which was a real pain to get apart. It was mounted underneath, I think, the magnetron or something. So they did start making some horrible versions of these. These earlier ones, very quick to diagnose. Some of the later ones in those sort of more square-shaped boxes can be really horrible to work on. I was glad when I finished working at a place that was doing those Sharps, and they're only paying us the same under warranty for something that took, 4 times as long to diagnose and fix. We've got a fan in the back. Fan needs to run to cool the magnetron. It basically sucks air through, I forget which way they turn, but I think it sucks air through the door, down this sort of through the vent on the side, around this path here, through the fins of the magnetron. There's some aluminium fins in there, and back out the back of the microwave. I think they do that to keep the dust out the back. I think, yeah, from memory, the back grill on these used to get greasy from the grease out from the cooking, and all the dust would stick to the outside of them. That was another thing that often needed cleaning up. Yeah, turntable motor. We'll have a quick look inside this thing. It's only a little tray, and yeah, disgustingly horrible underneath there because the inside's all rusted. Now this has actually got the full rollers attached to the shaft of the motor. Sometimes they have this roller bit separate, of course, and then just this part that fits down. Now sometimes these would get broken, the little coupling part that goes in. There was a Sharp microwave that they'd actually designed it somehow that the cavity, as they call the inside here, because it's microwave, the bit where you do the cooking inside, actually directed all the beams onto this part, and they would actually melt them. So their fix was to actually take the turntable motor cover off and put a screw through one of the holes under there to just bend the bottom of the microwave up ever so slightly, so that the microwave beams or microwave energy was sort of end up somewhere, all concentrated somewhere else. Basically, it had a hot spot somewhere that wasn't on the turntable coupling. But you occasionally have to fix those. Occasionally the turntable motors have stopped working. I looked at a really ancient one a few weeks ago in the local hall, and that actually had a belt-driven turntable, which I pretty much forgotten any of them even had that. Some of the early microwaves were a bit different. Broken belt, but we ended up replacing that with another one anyway. But generally there's a little synchronous motor underneath. Might have a look at that later. That's the inside of this one, absolutely horrible. Now the other thing you can get is arcing and stuff. They all have one of these what they call a waveguide cover, because we're talking in microwave radio terminology. And the waves out of your microwave device, your magnetron, basically have tuned like metal tubes and stuff that they travel down. And that one just pops out. Some of them have a screw holding them. If these get grease and stuff left on them for long enough, sometimes they get a whole layer of grease around them, they will start burning, because that grease will cook each time you run the oven, and they will start sparking and carrying on. These can get quite burnt up. Used to just buy this by the sheet. You could obviously get the original from the manufacturers, but you could just buy it in a sheet. I've still got one here somewhere, and you just drew around the old one with a pen and cut out a new one with a pair of scissors. That meant you could pretty much do them on the spot. Sometimes up inside, behind this metalwork here, there's a bit of a cavity, as they call it, and there's a piece sticking out the end of the magnetron, ceramic bit with a metal cap. If there's enough muck get up in there, that can actually start sparking as well. I've had magnetrons where the end cap was actually fairly badly burnt, and I think it was just from a lot of grease. I think I actually fixed one for someone by just getting a scrap magnetron and pulling the same metal piece off the end and putting it on their one. Saved them having to pay $80 or whatever for a new one. and just cleaned up around there, and it kept going fine after that. But pretty rare you ever saw anything like that. It's usually just this cover. And yeah, the dirtier the microwave, the more likely to get... Oh, I haven't got it under that piece. That won't matter because we're going to chuck this out soon anyway. And yeah, issues with paint peeling off and stuff was a thing you could actually buy from places like repair parts, places like Wagner. You could buy microwave paint. I might even still have a little tin of it somewhere, some sort of enamel paint in white. Don't think it matched all of them perfectly, but you could patch up chips and bits where, yeah, the turntable had started just cutting through or something. You could often patch them up and keep them going. Because I think even the paint can sometimes arc to things, or the metal can, where the paint's come off. But that's a grotty looking thing in there. We might even put the turntable back in there and we'll fire it up and see if it runs. And of course, as you probably know, you shouldn't run these without a load in them, because the magnetron will just be pumping out a heap of energy and it will just bounce around in there, and some of it will come back into the magnetron. I do not like running without a load, so you need something to absorb it. Normally just a cup of water is the most convenient thing to put in there. It gives the oven a load and you can see if it's warming up enough. And the way to test the power on these, I forget the exact formula, but I think it was about a litre of water you put in there. You measure the temperature of the water when you put it in, like the tap water temperature or room temperature, wherever you've had the water sitting. You run it for a minute, I think, and you measure the temperature again. Might have been 2 minutes. The sharp microwave manuals and that used to give you the formula, and then you'd measure measure the new temperature, how much it had heated up, and then there was some little formula where you subtract, I think it's just the difference between the two temperatures, and that somehow related back to the actual power output. So the amount of degrees it went up related to how much power. Of course, the earlier ovens were all around 600 watts. These later ones are more like 900, even 1,000 watts. That was more like a industrial or commercial oven back then. Back when they first came out, it was all pretty standard to be 600-700 watt magnetrons. And yeah, later ones they went up more, so you've got to know the rating of the oven as well, of course, to get an idea. This one actually says 800 watt compact microwave. So this is an 800. So you need that temperature difference formula to work out that it should be close to the rating of the oven, because these magnetrons do lose power over time. Possibly also because people have run them without a load or something might have damaged them a bit. But I think the emission just goes down like any other. It's basically just a valve type, electron tube type device, or picture tube, even the same thing. All of these things, they've got a heated cathode, and the emission, for whatever reason, of the cathode loses material or something, and it doesn't work as efficiently as it used to. It doesn't emit as many electrons, so it doesn't do the job as well. But that's something else you can test on these, which you normally would do as part of your normal check over, and especially if you're going to fix up. I used to fix a few old second-hand ones up and sell them, and you'd make sure your magnetron was up to power before you did that, because if the magnetron's getting tired, yeah, it's time to fit another one or chuck the oven out. They really weren't worth a lot even back then, except for the convection type ovens. Of course, that's something else we should probably discuss, is a convection oven just has up here somewhere, usually you'll get a standard oven element, like a horseshoe shaped type thing, and maybe an extra fan and stuff for that. But a convection oven just has a standard element, like a resistive element, and just a bit of extra stuff to cook things like a grill basically, as well as the microwave function. Whereas these are, yeah, a radio wave type emission device. Completely different type of technology. There's no heat comes out of this per se, though it does heat up, and that's why it needs a cooling fan. But no actual heat is injected into the oven from this. It's all just electromagnetic radiation, and it's basically just like a higher frequency version of light. And heat is just infrared light pretty much anyway, so this is just a even higher frequency. Doesn't directly heat it, but it irradiates the thing and gets all the little electrons excited in there, and that's what heats them up, because you're basically putting energy into them and making them vibrate or altering their orbits or whatever, the electron orbits or whatever, something like that. Whatever the latest science is on that, I probably haven't even kept up with that for the last 20-30 years anyway. So I'll get a load to put in there, something to fill with water. Well, I've got a nice Cascade beer glass from the tip shop. That's the closest thing, and the water is very cold at the moment. That should just fit in there. I guess we better actually plug it in and see if it does even light up on the clock. Which it does. Where are we? Oh, reset. 1 minute. Might get this out and we'll put a 9-volt battery in that. So this, I think we have to zero it out. I think that is more a battery test. When you go the full way up, should have a flashing light to say it's working. We get milliwatts a centimetre cubed. Let's check it and go around the door. No sign of anything, which is what we want to see. I can hear the magnetron, it makes a buzzing sound as it starts up. And glasses going around, fans running, lamps lit. So I'll give that a minute's run. Let's see if our water is at least warmed up a bit. No, it hasn't. That, I don't think, did a thing. Even though it sounds like everything's running, so this one is actually faulty. Now this is where you often got to check your high voltage and stuff, because everything we measured seemed okay. But when you set the time and press start, you will hear the transformer will hum. This thing will make a bit of a buzzing noise as it starts up. That's your transformer, and then yeah, not much. It is fairly quiet, but it is buzzing, so it should be working. Oh, actually, it's making a bit of a funny noise. I think our magnetron's dead. Yeah, it doesn't sound the best, that magnetron, to be honest. One thing that can cause either intermittent magnetron or magnetron, everything sounds like it's running but it's not doing any heating, is those lovely round magnets they have in them can actually crack. So that's another fault you get, because this to me would suggest it's running. I might even do a high voltage check on this one. Oh, there's my other. Yeah, that's your TV type one, but this only reads kilovolts in the positive, and you definitely can't reverse it because you don't want to stick any high voltage up that earth probe because it's not insulated for it. Technically you might be able to get away with it, but you definitely wouldn't want to touch it or anything, so best to buy the proper probe. But we might probe on the cap there, see if we've got the voltage. Obviously the voltage after the capacitor, where the diode is, will be DC. But it'll be AC before that, but I don't think I've ever actually... Have I measured the AC side of it? Only to check the filament voltage, I think. Now, I think the way to check the filament voltage is you've really got to put your multimeter across there. And it's your multimeter is going to be sitting there at 2000 volts. You just sit it on something insulated. Because I don't think... I'm not sure what the... They can handle a 1000 volts reading, but you're only reading... I think they're 6.3 volt like a normal filament. I think the only real way is to put your multimeter, plug it in across the two terminals of the magnetron, and you just, like I say, insulate it. Make sure, I think these test probe leads are rated, but you just sort of keep everything away from earth, because your multimeter is going to be rising to 2000 volts potential relative to earth, but it's not actually 2000 volts across the multimeter that it's trying to measure. But you just, you don't want to hold the multimeter or anything while it's at 2000 volts, even though it's a fluke or something's probably rated for it, though mine's been dropped a couple of times, so I don't think that's got very good voltage rating anymore. Very good insulation properties. But what we can do is dispose of the original leads. We'll plug a high voltage probe in. The fact that magnetron's making that noise suggests we have our voltage there. I'll keep that well out of the oven. Did I take my load out? I think I did. Naughty. even though it doesn't seem to be running, if it's got cracked magnets or something, it might start running, so we'll put the load back in there. And yeah, we're looking for the, in this case, the top pin of the capacitor is where the diode is, so we're looking for negative, what is it, I think it's a 1/100th probe. Yeah, doesn't tell me. Yeah, make sure you got your thing grounded. I thought I had it stamped in the side of it here somewhere. Am I missing it? Usually they tell you how much they divide the original voltage by. Probably came with it. I knew it when I bought it, but I've forgotten. I'm not sure if we're looking for 20 volts or something. It'd be something like that, I think. So let's start this thing up. Keep our hands and everything well away. Minus 2.7, so that might even be a bit high, although this is a higher wattage than some of the earlier ovens. But that's 2.7 kV we've got there. Probably the magnetron is not pulling any real power. Well, this is a little bit left on that capacitor there. That's 500 odd volts. So that is a sign that the magnetron is not good. Also means that capacitor possibly does not have a discharge resistor in it. This is a sort of scenario I've had before where the cap, when I put the clip lead on it, just sparked a little bit. Which is why you always discharge it. Just going across that diode to ground should be enough. Always hook the ground side of your lead up first. And make sure you go across the actual terminals of the cap anyway. So it's definitely shorted out. You never know what's connected and what's not connected in these. So ground should short it out, but never trust your transformer to be intact or your high voltage fuse. If the high voltage fuse isn't intact, you probably won't discharge your cap. Not to ground anyway. So I'm pretty sure this magnetron is dead. I guess we could try measuring the 6.3 volt filament, but the fact it's buzzing, I'm actually thinking I'll just pull this thing out, which is a very simple job. There's only the whatever rubbish we have here. Sometimes thermal fuses, they can just be unplugged and left on there, and anywhere from 2 to 4 screws holding the rest on. Is that one screwed on? This one might just be a 1 screw job actually, I think. I think we take that cover with it, we take the screw off this side, and I think it, yeah, this one slides up and unclips or something. Yeah, this is, I forgot some of these only had 1 in them, so these modern ones, they've done away with everything. You can inspect your magnets. Sometimes you'll find these, if these have been really hot, these aluminium will look a bit melted in the centre there, or they're all bent up to one side. Should really remove that cover completely, but I don't see a cracked magnet anywhere. But that can be something that causes intermittent, or the magnetron sounds like it's running but it's not. In theory we should check the filament, but I've already measured that it goes to ground, so it's going to be there, I would think. Only thing that really takes out filament voltage is an open circuit transformer. I'm sure I had one once, and only one ever. So as expected, this is a write-off. Magnetron's dead, which is good because we can pinch the magnets out of that, which is all I grabbed this thing for. Plus that transformer can go in the scrap metal. I used to keep a few of them just because, especially with these cheap ovens, if you had a second-hand one you could slap in there for someone for 40 bucks or something and get the oven going, they were happy to get it going again. Occasionally they will burn up. I think Sharp, there was a particular model of Sharp microwave, one of their early sort of mid-80s type models, that every transformer in it just died because they were a badly designed transformer or whatever, shorted windings or something. Sometimes you would, I think, get a shorted magnetron or some other high voltage thing and it could burn out the transformer. Pretty rare, unless someone's changed the value of the fuse or something. But occasionally they did die just from you'd just look at them, you'd have the usual blown fuse, couldn't find anything shorted in there, maybe put a new fuse in it and try it and I'd blow it again. if you hadn't already noticed, like often the secondary upper winding would be blackened and smell burnt. So that was another issue you used to get with these things occasionally, but it was pretty rare. I used to have like 20 or something transformers out of various microwaves, I think, and I may have used 1 or 2 of them over the years, and the rest just ended up going to the scrapyard when I shut the business down because you just rarely used them. But there would have been a few other ones I'd used over the years. Like I say, sometimes you get a second-hand one that someone gave you, or a customer had one, and yeah, it was over $100 I think for a new transformer. So you say, look, if you're happy, I can put it's this much to fit a new one, or it's this much I can put a second-hand one out of a known reasonable oven, not some Chinese special, and it would probably last the oven till as long as the rest of the life of the magnetron or whatever. But this is one of these cheapo brand, unknown sort of brand ones. Yeah, I think that's filament A and filament, it's got F and FA on there. But this one's not leaky. Often they went leaky, but sometimes they will kind of run leaky, or short was the main fault, but sometimes they'll run but not heat. But the easiest way to get the magnets out on these, I put my foot on it and bang these tabs. Sometimes I have the 2 separate tabs, and I bang them with a hammer, club hammer, and you can just bang these. You'll just bend because the metal just goes in there and is bent over. I don't know if we can see that under there, but there's a little metal tab that goes in and it's then pushed across. So if you just bang them one way, bang the other ones, or sometimes just keep pushing it over. And then this whole inner piece, which has got the ceramic bit, it's got a big copper bit with these aluminium fins shoved on it. You just pull that up, magnets sort of come loose, that little brass thing in there comes loose. You just keep pulling on it. You can get there's a couple of coils of wire with ferrite in them in the bottom here, and you can just stretch them off, snip them off, recycle a bit of copper wire there. You can get your 2 magnets out, and you just chuck. I think I used to throw them in the irony alley bin with all the fins and the copper in them, and you can recycle most of them. I didn't even bother getting the magnets out of them. I got so many of them, I just threw the whole lot in the irony alley and sold it with all the old transformers and video heads and whatever else I was getting rid of. But we'll pull that to bits. I think the ultimate recycler was using pliers or something. I said you should hit him with a hammer, so maybe if he's watching this you can learn my technique, which is a little bit easier. I think the rest of this thing we'll just scrap it. So when it comes to replacing the magnetron, I'm trying to remember what the differences were. There was like probably around 10 different types at least. You've either got these big tabs, or you had this center part cut out 4-tab type design. And there's something to do with the airflow. I think, oh that's right, where these terminals are, some are in line, like coming out here with the fins, some are at 90 degrees pivoted off to the side of the fins, so they're not in line with the airflow. The brackets were different. You had to measure the dimensions across here and across there, I think. So some of them are different dimensions as far as the size of it. I don't think the depth ever really mattered. They're all the same. Not that anyone's probably going to be fixing any 80s microwaves anymore or anything, or even 90s ones, or even 2000s ones. Probably most of this stuff just gets thrown away these days. But if you've got to replace the magnetron, like these modern numbers don't mean anything to me anymore. The older numbers, I think, I forget what they used to have on them. We'll pull that old sharp one apart, I guess. I might as well do that at the same time. And we'll have a look at a retro one, because I know that one is low power. It runs, but it's pretty worn out. So we might as well trash that thing. And we'll have a look at I really can't remember what the numbers were on these things anymore, but the Japanese ones used to have pretty standard numbering system. And that was just a matter of, like, places like Wagner used to have a heap of different types, and you just bought an aftermarket one off them because it was a lot cheaper than the manufacturer's one. And they seem to work fine. I don't think I ever had one back. And maybe these brackets, that is the other thing. I think the Panasonic ones had the brackets on the other side, so maybe it was more the brackets than the HV connection, but you had to get that right, get your tabs either in line with the vent or opposite. was it a 2M210 or something the Panasonics had? They were a very common one, and they had the 4 tabs. They used to fail a bit. Their inverter ovens used to break down a lot too. I remember fixing lots of those, or at least diagnosing them. Quite a lot of them failed under warranty. We were doing a lot, either the inverter or the magnetron, or both sometimes, I think. I think the transistors used to blow in those. They had a repair kit. And yeah, the magnetrons fail in the same sort of way. But those Panasonics were not the most reliable. And their earlier ovens, I mean, there were so many of them around because they were quite a good oven. But you did see a few of their, a common, luckily I think all the Panasonics and even those later inverter ones had pretty much the same shape of magnetron in them. They all fitted the same, but I think the inverter ovens had a different type. All their earlier, maybe, not including the national branded really early ones, most of the Panasonic ones had the same magnetron. I think Sharp and that had, most of them were similar, but they did vary a bit. And then these later ones tend to be these, like one screw holding them in, these large tabs. I don't think I've ever ordered one for any of these later ovens because you generally throw away, and that's the problem. The paintwork and stuff's often stuffed on them by the time they fail anyway. So people are ready for a new one already. They just sort of run it until it finally dies. These lamps, worth keeping. Like you can, what I used to do is solder a couple of wires on these, and just, they're handy to dag across switch mode power supplies as a dummy load and test them. That's about their main use for them. A second-hand globe's not much use for anything else. But I tend to keep those things. They always had these nice little plug-in lamp holders as well. I was planning on doing some sort of project with them at one stage and never got round to it, so I think I threw out all the ones I'd salvaged. But we might as well scrap this thing out. Those thermal fuses used to be worth keeping. And I think most of these, you actually need to use a pair of, they got the little tabs. So you need to squeeze them with a pair of pliers or a pair of side cutters just outside the main spade terminal there. And these, always have a rating on them, 120 degrees Celsius. They come in different temperature ratings, so if you ever replace one of those, make sure you do it with the same type. Same with this has got the same tabs. Really nice made wiring harnesses in most of these things. We've got a three terminal fan, so I wonder if that's a dual speed fan or something, possibly. And one plug and one screw, and that's your power cord off. That was meant to be slotted in there. It must have come out when I was moving it around. So nice 3 terminal power cord I can use. That's another reason I grabbed it. I thought, well, I'll have it for the power cord if nothing else, because I'm always using power cords. And might as well keep the fuse out of it. What's this one? A 10 amp. They came in 6 to 10, 6, 8 and 10 was the main. Some even had 12s, I think. Not that I'm going to use a microwave fuse these days probably, but I'll keep it anyway. Much higher rated than most appliances. Though 12 amp is probably a bit high because normally the power points and stuff are only rated at 10. Now what I used to do, usually with a battery drill to make it quicker, is take the fans out of them because it helps get things out of the way, but that can go straight in the motor's scrap metal. But to get to the capacitor and stuff, you normally have to take these out. So I think for most of the time you could just toss the whole thing in there. I might just cut those off because we don't really want those spade terminals. That usually pulls off. In this case it's nice and easy. I think some were a bit of work to get apart. Kind of a shame to chuck these out because they're quite a nice little fan motor, but not sure what you'd use a naked fan like this for. They blow a lot of air and they're rather noisy, as everyone knows from cooking with a microwave. I don't think I've ever found a use for one of these motors. So unfortunately that's just a piece of scrap metal. But they're a rather nice motor, but they run at a high speed, so not much use for any sort of projects. It doesn't say anything about what RPM, but that can be recycled. Now we could take our diode off here. These, do these have the tabs? Yeah, I can see the tab. Probably better to use some pliers for that. If you put them in the right place, you can lift that little tab and it comes straight off. Not so easy when they've got plastic over them. So there's our fuse. I don't think that one's got a tab. So that's our high voltage fuse. Worth keeping, or they were. I don't do microwave repairs anymore. So occasionally it's handy if your own one fails or something, you might want to try and get it going. So can be worth hanging on to these sort of parts. I still have some in a drawer somewhere, so I'll probably hang on to these bits. That's our diode. They used to have a standard number on a lot of them. Often the older ones were square shaped or rectangular, I guess, a rectangular type thing, but basically one terminal for the cap, band, and a terminal eyelet to go screw to the chassis. And there's our capacitor. Usually got no PCBs written on it. Way too new to have PCBs anyway. Ningbo, China. Now that I think about it, sometimes these capacitors I think could even cause low power out of the magnetron. Probably wouldn't hurt to actually measure this thing, see if it's the right value. Sometimes these go bulgy and stuff, and then they'll short out usually. I think they can sometimes just pull a lot of power and blow the fuse or something, not be a dead short. So it shows it with a 10 mega ohm bypass resistor. Oh, actually I can't probably measure that high on my multimeter. I'd like to get a mega or something on that, because some of these Chinese ones, they either didn't exist or they went open circuit, I think. But now that I think about it, I think you can get similar symptoms with a faulty capacitor. Not that this oven's worth doing anything with anyway. It was always going to be a piece of scrap. What do we got? 1 microfarad at, yeah, it should be 2100 volts. So they run a bit below that. Well, this actually had, how much voltage? We had 27 across there. So this is technically, was exceeding its ratings. Let's go to the 4 microfarad range. And see what we get, if anything. Right on 1 microfarad, so I'll say that'd be fine. Pretty sure this one was a dead magnetron, but I forget exactly what could happen. And I think if you change the values of these, it changes the power output from memory, I heard somewhere. Don't think I've ever tried putting the wrong value in there, but they do come in all sorts of, like 1.13 microfarad, I think was the Panasonic common one, 1.08, etc, etc. All sorts of different values. So you're sort of tempted to put the wrong one in there sometimes if you've got a second-hand one lying around, but I think it might just slightly change the power output if it's close. Then we've got our door switches. These are another thing, especially in the older ovens, and when they had a lot of service life, you'd occasionally have to fix. Sometimes it's just one screw, sometimes more. It's one screw right behind the bottom one. It looks like we've got some wiring going across to our turntable motor there. We'll have to come out of the way. Usually these things unplug fairly easily. Have we got a little clip on the main power connection? And where does this go? Cable tie. Oh, that goes to one of the switches. So switches here, often a couple of screws, and they'll slot downwards or upwards and unclip as an assembly. So just a bunch of standard micro switches. These are Glan's brand as well. These got these lock tab type spade connectors as well. And what we used to do with these a lot of the time is, at least to inspect them, is you can actually pop these switches open. Some of the 3 terminals, the double pole, or double throw ones I should say, single pole, double throw. Some of these, some are normally open, some are normally closed. So you might have a terminal here, 2 terminals, 1 terminal here, 1 terminal there. And this one's not looking the best. You can usually pull these out and have a look at that. See, she's all pitted and blackened. Not terrible. If they get really bad, you just replace the switch. You can give them a clean. Sometimes you get grease down through and inside these and they'll stick and that sort of thing. And that can cause intermittent blown fuses and stuff. Normally I wouldn't bother using any of those second-hand ones. I might keep a couple because I may have a project for some of those. And yeah, you usually just got to bend these plastic clips out of the way. And that one broke because I was a bit forceful with it, so you do have to watch that because a lot of these later ovens, you got to be super gentle with these clips or they will break. And that one's got a little pin goes in the round hole. And yeah, really more trouble than it's worth to get these out if you don't have to. What's holding this one? Okay, we might abandon that one, it's going to be too much work. But I certainly used to stock these switches in case we needed them. So this is a double throw one. It shows you on the inside, normally closed, normally open. So normally closed, we've got a connection between there and there. Then when we press it, that goes open circuit and we connect from there to there. So that's the back of the controller. That's your keypad connector, so you just press these little tabs in, pull upwards. That comes out. I guess we might as well remove that from the plastic bit. Have a look at the other side, not as much worth looking at. There we have it. The old ones all had the fluorescent type display, later ones are just the cheaper LED one. I guess it's less electronics to run it, or less windings in the transformer. They normally needed a 30 volt and a filament for the fluorescent ones. And yeah, you got your main relay probably. Oh, there is an option for a grill on this. Maybe they did make a grill or convection type one. Oh, that's your main relay, VPC, whatever that means. Well, that would be the magnetron, I think. I think the main one does the fan and lamp and stuff. Yeah, this transformer's only got minimal windings, 2 secondary windings by the look of it. Often you get like 6 to 8 terminals on them, I think, because they'd have the filament and 30 volts to run the fluoro display. Yeah, not much else of interest in this thing. Some sort of custom microprocessor. And that's about it. Those relays can sometimes go and be worth keeping another one. The contacts will burn out or something and they won't operate. Like they'll click but they won't actually switch anything. Pretty rare they ever failed. I think there was the odd sharp or something that they used to. Sure, there was one model that was had a common issue with them. And that's the Galands as well, so they must be the company that made this thing. What are they called? Shundi Galands Electrical Appliance Components Limited. But given they've made just about everything in this thing, makes you think that they actually manufactured the whole oven. Oh, shit, there's a glass. And you always got to remember to get your glass of water out, because I was about to tip that up and make a mess and probably break the glass. That was always a bit embarrassing when you lift them up and your cup of water's still in there. The glass plate used to be worth something off these, but there's so many different ones. It was always hard to find one to suit your oven anyway. Four screws and your transformer's off. Some had less than that, but I think most had 4 because she's a pretty hefty beast. The only other real thing we have here is the door. It's got the latches on it, a couple of hooks. Occasionally people used to catch something on those and break them off. And yeah, we can have a look, I guess, on this one. I might take the door off it. We can have a look at door disassembly. I think the top bracket you normally take off and the other one just lifts off. That usually stays on the door, I think, though. There's usually a way of... Yeah, I don't think you can unhook this one until you take the door apart. The only thing left is most of these, some used to have screws in them, but then they made them so you have to cut the bottom off, because chances are the oven was going to go to the dump with no one ever touching it. won't bother fully undoing that because I don't actually want it loose. And there's another little motor, which, like I say, little synchronous motor. I used to save them in case I needed one for a second-hand oven or something, or to get someone's oven going in an emergency. Often people had babies, they warm the milk or something, so if they were in a real rush and I didn't have the part, I'd sometimes just put a second-hand one in there with their knowledge, of course. But that's just a bunch of gears in there, and I think just a bit of copper around the outside. I guess we could pull it apart for the fun of it, just to see what's in there. Since I have no intention of doing anything with it, especially out of an oven that grotty, it's probably not in the best condition. Yeah, they've just bent these tabs over, but man, they do not want to come undone again. But this little faceplate should lift off. I don't know if I've ever actually, I kind of remember what they look like inside, so I must have pulled one apart once upon a time, as I always intended to do. If you've got an old faulty one or something, always interesting to see how things are made. Actually helps understand when diagnostics and stuff. Yeah, so like I say, a bunch of gears. And can we just, looks like this bit sort of lifts out these metal bits here. So that's your main shaft. Yeah, I can see the coil down in there. Or is it attached some way? That's lifting the terminals. These terminals should lift the whole guts out of it, I think. There we go, it's just a very tight fit. Is that a magnet or something? Might be. Yeah, maybe that's how it works. It's actually got a coil. Looks like it's got just a spinning magnet there. That's the main gear. So you've got a magnet that rotates in a AC field. So there's a little copper winding. Very little there. That bit just, well, rips off. Rip the coil or wire out. That'd be good for fixing video head drum wiring or something, maybe. If you could get, I think they put glue on that. I know I've salvaged these sort of things just by going like so, and you can see the copper just splits off it. That's the other thing you can do, is bust all that off, I guess. But yeah, in theory there's a nice great big ball of winding wire there, if you weren't too concerned about exactly what diameter it was. So if you really want to get into the scrap metal industry and save every last little thing, I guess I should put some of that into the steel bin. You've got a few grams of copper there, very little, but at current copper prices, if it's anything like it was, it could almost be worth doing. That's not bright copper, it's got a coating on it, so it goes in with like the burnt copper, and I forget what they call it now, but it's the second grade sort of stuff. Much like the copper pipe with the chrome coating or whatever it is, so it's not prime quality. And of course we've got this massive transformer, nice lump of heavy scrap metal there. Now I always used to just toss these in the scrap bin because you see these great big weld marks across, so I just assumed, well, they're going to be pretty well joined together, but I've actually seen a YouTube video where if you smack this with a big hammer or blockbuster or something, you can actually break this whole plate off. Luckily they don't have, some transformers, they got this E-shaped core, so it's up the side, right down the middle to the edge of here. So it's like an E shape, and they'd have one this way with the end plate on it, and then the next one would be the opposite way with a little end plate up in here. So way more trouble than they're worth to pull apart. But these ones are like some of the old ones, you could just pull the bracket off, knock that bit off, it was just a bit of waxy stuff or whatever in there holding it together. And then if you held the copper coils on something, you could just bang out the E-shaped bit by banging it down through the middle of the coil. Now these have got all sorts of rubbish on them anyway, all this plating, so it's not very clean copper. But yeah, I might even try doing that. You can whack and break this weld, or maybe cut it with a grinder, but if you can just break it, and this whole plate will come off, and all this lower pieces of the laminations, and then you could tap that out. Now one scrap metal place I was talking to, probably not with these small amounts, but with this iron being some sort of soft, high permeability or whatever iron, good for magnetic stuff, is supposedly worth a bit of money. Because the scrap metal place I knew, he was getting like great big enormous industrial transformers and stuff, and he'd pull them to bits, get these enormous copper coils and stuff which are worth a fortune out of them. Well, it wasn't worth so much back then, but it was still worth good money. And he just took all this to the dump because steel wasn't worth anything then. And then later on he's saying, I was talking to some bloke in Sydney or whatever that buys some of the stuff off him, and he said, oh no, that just save it, because he used to dump tons of the stuff, great big sheets of the stuff. Save it, because he used to do all the hydroelectric stuff in at least southern Tasmania. So he got some really serious transformers and stuff, and like the old EZ Risdon zinc plant and stuff. And he used to dump a truck, fill half a truck up with the stuff just about and dump it, until he found out that is actually worth money. Whether it's, in small quantities, it's probably not, but it could be worth checking with your scrap metal guy. If you do pull these apart, or motors apart, you get all those rings out of motors. But I never bothered. Way back when I was burning some tree stumps or something, I used to throw some of the old TV transformers in, and if you burn them thoroughly, which, you obviously got to do it out in the middle of nowhere where no one's around, because God knows what sort of toxic smoke they put off, burning all that lacquer stuff off, but they will just fall to pieces, particularly the ones that don't have the alternatively placed things. So if they're just like ones with all this sort of muck, you can incinerate the things, but you need to burn them pretty well to get them apart, and then you just get some burnt copper wire. But again, it's probably not legal these days to even think about doing that sort of thing, because of God knows what noxious fumes are coming out of it. But when you live in the middle of nowhere, you could get away with that. But hardly anyone does anymore, because there's houses everywhere now. But that is like, I don't know how many kilos there, but quite a few, 5 to 10 kilos I guess. But yeah, whatever you do, do not go doing any silly stuff like hooking anything up to the outside of this. If you want to burn stuff on a wood or something, I would build it all into some sort of plastic box, and have a couple of bits of conduit or something coming out of it that you can manipulate the probes with. If you need to move the probes, do it on the end of a metre long piece of plastic conduit or something in a sealed box that no one can touch anything. But do not, under any circumstances, hook these things up to probes and hold one in each hand right where the current's going to go up one arm, through your heart and down the other one. And even if it doesn't kill your heart dead, it's probably going to fry all your internal veins and God knows what else. They may not be able to fix you up very well, even if you survive the shock of it, which will put your heart into palpitations or whatever. And you need a defibrillator, would probably get you revived if anyone's around to do it and has one nearby, but just don't do it. These are lethal, horrible things. Either destroy it in the scrap metal or save it for another microwave, but do not do anything silly with these things. Especially holding each side of the thing in your hands is one of the silliest things I ever heard of. But it probably is possible to seal them up in something so that no one can touch it, no animals can touch it, nothing like that. And if you need to manipulate the probes, have them at the other end of a long piece of very dry plastic. And the final part of repairing microwaves would occasionally be you'd have to get a new door latch assembly. I think that's about the only reason you ever had to pull these apart. You did get things like these plastic things could get burnt by something inside. I think you used to be able to get a sheet of this as well, stick on plastic. Sometimes people would break the outer door, so you could order a new one from the manufacturer usually. Maybe not so much these days. But to get into these can be a bit fiddly. This one's a newer one, so probably not so bad, but you've got to peel this plastic bit out. It's basically just clipped in. You see it's a bit flexible. There's clips going down on the inside, probably on the outside as well. This other bit's clipped onto it and onto the metalwork. But the problem is they used to go brittle. Some of them just had a very fine bead around them. Some of the old sharps and stuff, which were common for these going brittle and breaking. And it was always a bit of a job to get these things out without breaking them. And you kind of got to feel your way usually, once you know the model, because we're going to put marks on this if we're not careful. If it's just your own repair or something, probably doesn't matter so much. But we're starting to lift. Once you get one part up, it's usually not too bad. Where are the clips? There's a couple, they're going into this metal, I see, yeah. I don't think there's any real way of getting anything in there to do them. You've just got to carefully prise, and I don't think this, here we go. Sometimes they will break, sometimes just with a bit of force they'll just clip out, because you can't get access to this metal frame to actually do the things. But once they start coming, it's normally, yeah, see that's broken there. I got a little bit ahead of myself there, which obviously this is not something I care about, but I'm not sure if we can get it out reasonably well. This end's a bit funny. It's got something on the other side, I think. Got to be careful of the plastic on those bits as well. There we go. So yeah, this bunch of clips that as you push it in, they go down the side of this black metal piece, bend back a little bit until they reach their hole and clip in. Looks like we broke one there maybe. Everything else, it looks like they've made some fairly solid backs on these ones, and those ones have got little plastic bits up to here, so good on Sanyo or whoever made it for them for actually making them strong, even though they were very unlikely to ever be touched. And we can see some, looks like the bottom bit here just sits in. We've got a clip there, and there's the top bit also sitting in. That's a bit weird, but with a bit of unclipping we should be able to get this metal piece out. I'm not sure quite what the technique we need to use on this one is. This has got big clips on this side. Maybe we do have to push those out a bit. Oh, yeah, it looks like this bottom ones are only just in. Can we lift that a bit? And if we get these end ones off, sometimes you've got to use more than one screwdriver. I get a feeling there's another one in here somewhere. No. Yeah, this one's a bit of a weird one. Is there? I'm not missing anything, am I? They're usually not as difficult as this one, but feels like some of them did have screws, I think, through to the front bit. This doesn't seem to, but still doesn't want to come. That is just those, yeah. If we get this, just needed a bigger screwdriver. There we go, that's starting to get it. I think these other sides kind of pull them out, pull it sideways maybe, and then get the other end. That's it. And then this piece should just slide and, yeah, basically come off with a spring. So they were reasonably common to need changing. Looks like this one you can, there's no actual glass, is it? Oh my god, it's actually got glass in it. For a cheap oven, it's rather fancy, really. I wasn't expecting that to be glass. Huh. Well, that's rare. Normally that's just plastic. Sometimes you can get a nice sheet of perspex out of these things. Some of the bigger ones. Get a feeling I'd cut a couple of them up and use them for something. But that's an actual glass one by the look of it. We won't bother taking that out, but it looks like it's just clipped in. But yeah, that'd be fun trying to get that out in one piece, I would think. Yeah, I'm not even sure how they've really done that. It can probably be done, but you'd hope that would come as one piece if you ever had to do it. So that's the end of that. And I wonder if I can do it on the bench here. Probably not so easily. Could probably jam a screwdriver in there. And these magnets are great for magnetising your screwdrivers. But I might do a separate video. The camera's just about flat. So we'll do another video and we'll dismantle this. We'll try and dismantle our power transformer. And we'll maybe have a look inside that sharp microwave, because I might as well get rid of that as well.